little bit about the project 11. Now this, if you want to import the data, you go over here and it will prompt you to suppose a so you can suppose, if you select the first one, Emily underscore control. Remember, the control means like the baseline, and if you see, each subject has 3 sets of data. When he or she is curling with 2 kilograms of weight, 10 pounds of weight, and control mean without any weight. So let's compare the two extreme cases, control and 10 pounds. I can show you with one data here. So now we have a lot of columns, but you see, the first thing you would do, change this to column vectors and this one to exclude rows, and you just drag it to, because over here if you take a look, this one is, if you take a look, this is acceleration in z direction, acceleration in y direction, acceleration in x direction, and the first column is EMG signal. So what you can do here, pick this one and drag this to this one and then import it. So once they are in the workspace, so I can clear all again to, there is no workspace, so now I can redo this for you. Just import it. Now we have two variables. Now the first one is the time variables, the second one is the EMG signal. So let me write down this EMG 0, because this is just like control signal. So another thing, I can plot it right now just to show you how it looks like. X2 is the time domain versus EMG, and 0 means no weight lifting. So you can see, and then from here you can see the maximum. Where is the maximum point coming? This is important. The maximum is the millivolt signal which the biceps are producing. So this is healthy muscle or unhealthy muscle. So you can also see M0 equals to max EMG M0. So this is the value for the maximum. You can put it in the Excel sheet with this, like what is the max value here, to understand the difference between the weight. And another thing I would like to show you, that usually, let's import the other data. So what I'm gonna do here, pick another, I'm gonna close this one and import the other data from the same subject, but now this time I'm gonna pick 10 pounds weight. And now it will prompt you to do, you will replace this by column vectors, change this to excluded rows, and drag this column to up until here, and then import it. So now if you see, we have now 2 more variables in our workspace. So I will just say EMG 10. Oh, that's good. And now you see this, and the size is different. In order to keep the same size, I tell you a trick. The trick is, suppose if I wanna, okay, let's do one more thing. Figure and plot. I wanna plot this new time signal with EMG. This one. So you see we have 2 figures now, and each has a different time. Size is different, a little bit different. In order to keep the same size, what I would suggest you take, like from 1 second to 7 seconds. I want to clip this from 1 second to 7 seconds. So let's see what is the sampling frequency. So the sampling frequency is the difference between the 2 consecutive samples of the time domain signal. So it is 0.001. This is a DT. So frequency sampling is 0.001 inverse. This is 1000 Hz, so that's good. Now we can also plot frequency axis. Let's first of all pick for frequency axis. For that, first of all, let's figure out the pick the one value from. So I'm gonna select this indexing from 1001 sample to sample. So you will do it for both time domain signals. So XS, you will pick that value, and you can assume this is my new XS, and then you will pick XS. Either one is good. I can take this one. So you will. So now it has been XN. Now you have 6000 samples, and let's pick up signal EMG underscore 10. So EMG underscore 10 new signal. You will index at the same space, so that you should not have any problem. So now you can plot it with another figure to see whether you did it correctly or not. So you will plot new signal, a new time domain XSN, and EMG 10, EMG underscore 10, and let's do it with a different color, and then hit enter. So let's see. So now this is figure 3, and we have figure 2, which is from 0 to 10 point something, but figure 3 is from samples. Let's see if this is the same figure. I'm gonna copy this figure and Control C and bring it. Click on this arrow and just click on this, and then I'm sorry, you have to click on this arrow here, and then click on here. Yeah, this is the same figure, but now that red color figure is the indexing from 1 second to 7 seconds. That way you will keep the same consistency for each data set point. And now I'm gonna show you the Fourier transform, the max. Let's do the max value. So I'm gonna to M10 is max value. Just compare the two max value, EMG 10, you see 0.001, and M0 was very small. So this is clear our experiment was good, and you can report this max value. And you can see in this paper which I mentioned here, let me show you. You will follow the same paper to format your paper accordingly, and use the write down the method, procedure, and some figures. How did you collect the data? And the table is good from 0 to 2 kilograms to 10 pounds. What are the values of maximum values of the EMG signals? And you can report the Fourier transform. Also these bars, arrow bars, it would be nice to see the arrow bars for 0 weight, 2 kilogram weight, and 10 pounds of weight, and you will see the trend would be similar, like it is rising. MGC, sorry, the EMG value, the max value is rising. So this is how you would do. Let's do one thing, and then I will end the video. Let's do the Fourier transform. So GT, I'm gonna take this MG10N, and now I'm gonna make the frequency axis. For that I need to have the length of the signal, length of the new signal, which is about 6000. So let's make the frequency axis. That's good. And now let's make another figure, and now plot figure, yes, figure GT10. That's good. Just plot it. That's nice. So this is the EMG, the Fourier transform of EMG. You can see the largest peaks are coming in the bandwidth of 50, like from 30 Hertz to 40 Hertz. So the largest peak is very important. It is telling us that it vibrates between, like, you also see another data point. I would say just pick one data point to be consistent, and then draw the error bars for 10 subjects or the same subjects. Okay, thank you.